Hi Chase, time for another video lesson. So we're gonna start off here on section, wrong color pen. So we're gonna start off here on section 5.17. Okay, the parabola, and yeah, so this is the parabola. Okay, and in the parabola section, they say they're not interested in using the table method, where you put x and y points and calculate it. Although I still recommend when you plot a graph, if you're not sure, definitely use the table method, even if it's just to confirm. So the general equation is y equals ax squared plus bx plus c. Okay, so that's your parabola. Okay, so they say in your book, consider the sketch of the parabola. A and B are the roots, C is the intercept, and D is the turning point. These 4 points can be calculated. Okay, so basically there are 4 steps in order to sketch a parabola. 1, find x-intercepts. So how do we do that? We let y equal 0. Okay. 2, find the axis of symmetry. Okay. How do we find the axis of symmetry? We take, so these x-intercepts, we call them values a and b. The axis of symmetry is a plus b over 2. 3. The turning, 3 was actually the axis of symmetry. So this is actually step 3. Step 2 is the y-intercepts. So y-intercepts, as you should know by now, how do we do that? Let x equal 0. Okay, then we've done step 3 and step 4. Find the turning point. Okay, so sub in x equals a plus b over 2. Okay, so we're substituting x equals a plus b over 2 into f of x, and that will give us our turning point. Okay, so let's take a look at example 24. Okay, example 24 says sketch the parabola y equals x squared minus 3x minus 4. So step 1 is find the x-intercepts. How do we do that? So x-intercepts, let y equal 0. So we have x squared minus 3x minus 4 equals 0, which we can factorize. Now, this equation factorizes normally. Bear in mind that you might have to use the quadratic formula. X equals plus minus square root of b squared minus, that formula. 4ac over 2a. So you might have to use that to factorize here to get your x-intercepts, but in this case it's not necessary. So it factorizes into x minus 4, x plus 1 equals 0. Therefore, x equals 4 or x equals minus 1. Okay. Step 2, find the y-intercepts. So y-intercept Therefore, let x equal 0. So if we go y equals x squared minus 3x minus 4, let x equal 0, we get y equals minus 4. So that's our y-intercept. Step 3, the axis of symmetry. So remember, we said this is point, we can call these values a and b. So we take a plus b over 2. So 4 minus 1 over 2 equals 3 over 2. Okay, and step 4, find the turning point. So we substitute in our axis of symmetry in for x. So once again, y equals x squared minus 3x minus 4. We substitute in our axis of symmetry. So y equals 3 over 2 squared minus 3 times 3 over 2 minus 4. And y equals, in the end, then in the end we're left with y equals minus 6 1/4. Okay, and there you go. So now the question is, how do we sketch this all onto a graph? We don't even know how a parabola looks yet. Well, I'm sure you remember, but we haven't discussed it yet. So there's our Cartesian plane. 1, 2, 3, 4, 5, 6, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, 1, 2, 3, 4, 5, 6, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. Okay, remember to label all your axes and so on. I'm not going to do it now. Okay, so our x-intercepts we solved as x equals 4 and x equals minus 1. So the x-intercepts are going to be, let's do them in red. So x-intercepts are there and minus 1. Okay, our y-intercept is at minus 4. 1, 2, 3, 4. There's our y-intercept. Okay, our axis of symmetry is at 3 over 2. So 3 over 2 is 1.5. So our axis of symmetry is a vertical line. It's the axis of symmetry. So the axis of symmetry is basically the line x equals 3 over 2. And then our turning point is a y value. So the turning point that we solve for, we solved the turning point equals, what did we say, minus 6.25. Okay, which is 1, 2, 3, 4, 5, 6. And the characteristic that you need to know about the turning point is that it sits, remember how we solved our turning point? We substituted x equals 3 over 2 into our equation. So the turning point sits on this x line. And the turning point is a y value. So it's essentially, the turning point is at the ordered pair, 3 over 2 minus 6.25. So we just plot that point and we have our turning point. So 1, 2, 3, 4, 5, 6 1/4 is round about there. Okay, and now we've just got to draw our parabola through all of these points. So there you have it. There is your parabola. Okay, and that's how you sketch a parabola. And remember now to label, well, you've marked these points. I would personally just label them. So this x-intercept is the point 4, 0. That x-intercept is the point minus 1, 0. Okay. This line here is the line x equals 3 over 2, which is our axis of symmetry. Then we've got our y-intercept, which we can label as, what was our y-intercept? It was minus 4. So that is the point x equals 0, y equals minus 4. And our axis of symmetry we've done. Our turning point lies at the point 3 over 2 and minus 6,25. And that's really all there is to sketching a parabola. So let's just talk about some properties of the parabola. If we do the vertical line test on it, you'll see that a line only ever cuts once. Therefore, parabola is a function. Okay. What else? If we do the horizontal line test, you'll see that the horizontal line cuts twice. So, parabola has no inverse. Okay. Then let's talk about the domain and range of this specific graph, because they are different depending on what parabola you've drawn. So, for the domain, that is our x values. Now, if you look at our x values, do you see that this parabola just goes on and on and on forever, and the x value just keeps increasing, and the same on this side. So essentially, the parabola starts at negative infinity, if we look at the x values, and carries on all the way to infinity. So, the domain is x starts at minus infinity and goes to infinity. You'll note that I didn't include the equals here, because you can never be equal to infinity. So you can never have that when you're talking about infinity. Okay? Then let's talk about the range. Those are our y values. So, if we're talking about the range, do you see that our parabola starts here at this point, minus 4, and carries on all the way, and it keeps increasing to infinity. So the range is minus 4, and it includes minus 4 all the way to infinity. And you see no equals because there's an infinity there. But it includes minus 4, so I've got an equals there. Okay. They've got an example here in your book. There's just one thing that I want to tell you. Example 25 in your book, I'm not going to do this. Just one thing I want to tell you. If you've got y equals ax squared plus bx plus c, okay? If a is positive, your parabola is generally shaped upwards, okay? And if a is less than 0, so if a is negative, your parabola is going to shape downwards like that. Okay. And that's really all you need to know about parabolas. There's one nice thing that they told you towards the end here. Another way to get your line of symmetry, so your symmetry line. The parabola is symmetric about the line x equals minus b over 2a. Okay? And that, when they talk about minus b over 2a, they're talking about this a and this b over there. Okay? So then you can substitute in minus b over 2a into f of x to get your turning point. Okay? Alright, let's get a new page. And we'll move on to something new. Okay, so our next section is the exponential function. Okay, the exponential function, which is 5.18. 5.18 exponential function. Okay, the general equation for an exponential is y equals a to the x. See, x is in the exponent, that's why it's called the exponential function. Okay, so generally with the exponential function, it looks like they just teach you to use the table method. Okay, so very simple. We're going to do this quickly. They say sketch the graph of y equals 2 to the x. So remember the table method, we've got x and y, and we choose our x values. Generally we want some negative values and some positive values. So here we're going to go minus 2, 1, 0, 1, 2. Okay? And we're just going to calculate, so we're going to go, here it's going to be y equals 2 to the minus 2. Then this one is y equals 2 to the 1, 2 to the 1, okay, and so on. So you just pop each value into your calculator, or you can generate the table automatically on your calculator. But please just remember, if you do that, to actually fill in this table in your exam, because they're going to want to see that. Okay, so if you pop them into your calculator, you get 1 over 4, 1 over 2, 1, 2, and 4. Okay, so the next step would just be to plot it. Okay, so this is our first ordered pair, second, third, fourth, and fifth. So let's just plot those guys and we'll be good to go. I'm not going to draw in any points, or you always must label your graph, draw in your points nicely. I'm not going to do that here for the sake of speed. So x is minus 2, y is a quarter, which puts us round about here. Let's say here. Okay, x is 1, y is a half, which is more or less here. Wrong color. Here. X is 0, y is 1, that's over there. X is 1, y is 2, that puts us over here. And x is 2, y is 4, that puts us over there. So I've just plotted these ordered pairs, and then you can draw your graph. Okay, so that's how the exponential function looks. So you'll notice it's actually got an asymptote here on the x-axis. This line will get closer and closer and closer and closer, but will never touch the x-axis. And on the right-hand side, this graph just gets steeper and steeper and steeper and keeps increasing all the way to infinity. So yeah, you can test this asymptote. If you substitute in x to the minus 1000, you're still going to end up with y being a very small positive value, which is why it never touches the x-axis. Okay, so that's basically all your book covers about this. I just want to point out, so you've got two kind of exponentials. So the form is y equals a to the x. So if a is greater than 0, your graph will end up looking like this. Okay. I lie. If a is greater than 1, your graph will end up looking like that. Okay. If a is less than 1, your graph will end up looking like this. And this is actually bad because there. Okay. A is less than 1. Okay. If we look at the domain and range of this function, so the domain, let's look at the x values. If you look at the x values for either of these graphs actually, do you see that it continues like along the x-axis forever this way, and also forever in this direction, because it just keeps going. So the domain x lies between negative infinity and infinity. Okay, if we look at the range, this applies to both of these, by the way, a greater than 1 or less than 1. If you look over here at the range, do you see that? Remember, we said the graph gets closer and closer and closer to the x-axis but never touches. So it starts at the x-axis but not including the x-axis, and increases all the way to infinity, because you see this keeps going up, up, up on the y-axis. So range y lies between, and it doesn't include 0, because it gets very close to y equals 0 but never touches. So we don't have our equals there. No equals. Y lies between 0 and infinity. And also, we don't have the equals here because it's infinity. You can never be equal to infinity. Okay. If we look at our exponential, okay, you'll see that with the vertical line test, it only ever cuts once, so it is a function. The horizontal line test also only ever cuts once, so it has an inverse. Okay, so the exponential is a function. The wrong color. Exponential has an inverse. Okay, and you'll also see that the graph is continuous because I can draw it without ever lifting my pen. Okay, the inverse, remember how we said you get inverses, so the book just shows you here how to solve for the inverse. So y equals a to the x. To get the inverse, what do we do? Okay, to get our inverse, we swap x and y. So x equals a to the y, and then we solve for y. So log x equals y log a, y equals log a log x over log a. Okay, your book did it with ln. It doesn't matter whether you do it with ln or log, really not an issue. Okay, so just remember as well, it's got an asymptote here. The x-axis is the asymptote, and you'll see that if you do the table on your calculator or by hand, you'll notice that. Okay, the next section is 5.19, which is the log function, logarithmic function. Okay, the general equation is y equals log base a of x. Oh, by the way, there's something very important. I forgot to mention it about the exponential. The exponential always crosses the y-axis at the point y equals 1. Just so you know. Always crosses at y equals 1. Anyway, back to the log function. There's our general form. Log base a of x. So basically the way you're going to plot this is the same way as you plotted the exponential. Let's see how your book teaches you to do it. First, write the exponent in the form 2y equals x. Draw up a table for the exponential function. Calculate the corresponding x values and sketch the graph. Okay, alright. So, because log is the inverse of the exponential, what they teach you to do is write this in the form, or basically solve this for x. and then so what they want you to do here is solve for x. So write it in the form, let's just check. Sorry, I just don't want to make a mistake here. This is not a method I'm familiar with. Write the exponent in the form 2 to the y equals x. Okay, so they're just going to say, they're just going to take a to the x to this whole equation. So a to the y equals x. Okay? And now what they teach you to do is they reverse your table. So choose y as your independent variable and x as your dependent variable. And then substitute y values into this equation and get x as your output. Okay, so they give the example here. Sketch the graph. Y equals log base 2 of x. Okay, so we can write that as 2 to the y equals x. Okay. And now we're choosing y values to put in here, and we always choose our values around 0. So we're going to go -2, -1, 0, 1, 2. And yeah, then we're just going to calculate them. So x is equal to 2 to the y, so we substitute in our y values. So -2 goes in, 2 to the -2 equals 1 over 4. And we substitute in the rest of the values, we end up with this. Then we plot these values on our graph. So, but we plot them the normal way around. So here's x and y. So our first ordered pair is 1 over 4. X is 1 over 4, y is -2. So that's somewhere here. Okay. Then our next point is x is a half, y is -1. So that is somewhere there. The next point is 0, 1. X is 0, y is 1. Somewhere there. X is 2, y is 1. That is somewhere over there. And x is 4, y is 2. So that is somewhere over there. And then we can play join the dots. And you end up with a function that looks like that. And that's your log function. So that is your method for drawing the log function. So switch around your x and y. Or not switch around. Solve for x. So get the function written as x equals a to the y. And then choose y as your independent variable. And calculate your x values based from this function. And then plot your points normally. So plot x, y as ordered pairs. And then join the dots. Okay? So yeah, that's really all there is to it. You get, once again, two cases. It's exactly like the exponential. Y equals log ax. So if a is greater than 1, your log function looks like this. Okay? If a is less than 1, your log function is going to look like this. Okay. But the method of calculation is exactly the same. So I'm not even going to go into it. I don't think you'll have a problem. One thing that I'd like to point out to you is that you can actually do this on your calculator just by typing in, if they asked you to sketch y equals log base 2 of x, you could literally type y equals log base 2, like get your calculator into table mode, enter this equation, and say, start at -2, end at 2, step of 1, and it'll give you the table and you can draw it. So if you want to check yourself, like this is the method they're teaching you, so they probably expect you to use it. But if you want to check your graph, type this into your calculator, get the table from your calculator, and make sure that you've done it correctly. Okay, so let's just look at the properties of these graphs. Let me do it over here. Just going to draw a generic log function. Okay, log, firstly, passes the horizontal line test, so log y equals log a of x has an inverse. Okay, if we do the vertical line test, you'll see also it passes the vertical line, it only ever crosses once, so y equals log a of x is a function. Okay. Next, let's quickly look at the domain and range. And generally, you shouldn't remember this domain and range story. You can just figure it out after you've drawn it, you know. Like in general, you don't need to remember it. If you know how to draw it and you understand domain and range, you don't need to remember what the domain and range are. So there's a generic log again. If we look at the domain, those are x values. What you'll see by plotting it is that this function will get very close to the y-axis but never touch, and here it'll extend on to infinity and look like that. So if we look at the x values, it starts at x equals 0, not including 0, and extends to infinity. So the domain is x lies between 0 and infinity. You'll note I don't have an equals here because the graph never actually touches the line x equals 0 and it goes to infinity, and you never have an equals with infinity, so that never goes there. Then the range, okay, if we look at the y values, do you see that this graph goes all the way down to negative infinity and extends all the way up to positive infinity? So our range is y lies between negative infinity and infinity. Once again, no equals is here because infinity never gets equals. Okay, let's see if there's anything else interesting that they want to tell you about it. I don't think so. No. Okay, there's really nothing else. Nothing else here about the log graphs. They've actually got a couple of examples where you sketch log graphs. I'm not going to go into it. I don't see anything really different to what I've shown you here. I feel that we've covered the basic, so I wouldn't worry too much about it. Sketch the graph. There's nothing. Yeah, there's really nothing much extra to it. As I said, just practice before your exam. What I'd recommend is just practice plotting each one of these kind of graphs. Just plot it manually. Using the table method or whatever method we've taught you, and then get the table on your calculator and check that what you've drawn corresponds to the table on your calculator, and then you should be fine. So yeah, that's about the end of this section, and we're gonna go on to sketching trig functions. Okay, sketching trig functions. Okay, so they jump straight into an example in your book. So I'm going to do exactly the same thing. Sorry, I'm just trying to get a white pen. Okay, so example 32 says, so this is, section 5.20. Sketching trig graphs. Example 32 says draw y equals sine x for x between 0 and 360 degrees. Okay, so how are we going to do it? With our table, of course. So we've got our x value and our y value. And we're going to go in intervals of 30 degrees here. So we've got 0, 30, 60, 90, 120. This is a long table. 90, 120, 150, 180, etc. I'm not going to put in all these values. So all you do is you pop in this and you calculate the value in your calculator. So you type in y equals sine 0, and then it's going to say 0. Then you type in y equals sine 30, and you're going to end up with 1/2. So put that in your table, and so on. So let's just put in the rest of the values. 1, 0,87, 0,5, and 0, etc. Okay. Once again, you could do this using the table function in your calculator that I've explained how to use. You could type this in. You go mode table, and then it'll ask you f of x equals. You type in sine x. You press equals. It's going to say start, and you're going to say at 0 degrees, or wherever you want to plot it. You say at 0 degrees. It's going to say end. You're going to say at 360. It's going to say step. You're going to say 30. It might give you an error because it might be too many points for the calculator to calculate. So then you maybe step it in steps of 45 degrees. And yeah, it's going to throw out this whole table and give you all the values, and then you could just fill it in. Calculator will do that for you. Alternatively, if you wanted to do steps of 30, and remember I said your calculator can only do up to 10 points. It can't do any more than that. So what you can do is just tell it to start at 0 and end at 180 in steps of 30, and then do the same calculation, write down these values, do the same calculation again, but tell the calculator start at 180, end at 360, step of 30. Okay? And if we plot these values, one thing to remember as well with your calculator, remember here we are working in degrees, not radians. So make sure your calculator is set to degrees and not radians, and make sure you know how to change your calculator between degrees and radians for when you need it. Okay? So what we've got, remember to label your axis properly: 30, 60, 90, 120, 30, 60, 90, 120, 150, 180, blah blah blah, to 360. Okay, remember that, and remember this is -1 plus 1, and x-axis, y-axis, etc. Okay, and if you plot those points, it's going to come out looking like this. And there is your sine graph. Okay? I'm not going to go through this whole procedure again for the cos graph. Literally, you can either follow the same procedure I've explained here, where you manually calculate each, you do steps of 30 and you calculate each one. So you'd say y equals, now we're doing cos, so you'd say y equals cos of 0 degrees. You'll get your answer. Y equals cos of 30 degrees, get your answer, etc. Or you can pop it into your calculator. Make sure that you don't try calculate more than 10 points because you'll get an error. But you could populate it or pop it into your calculator and get the table given to you from your calculator. And yeah, then what you'll end up with is a graph that looks like this. It's going to do that. Sorry. Starts at 1. It goes down. And that is your graph of y equals cos x. So it's unnecessary for me to do the whole table again, but that's what it's going to end up looking like, in case you're wondering. So it's going to start here at 0 degrees and 1. It's going to cross at 90 and 0. It's going to reach the point 180 and negative 1. Then it's going to be here at 270 degrees and 0. And then it's going to end here at 360 and 1. And just be careful. Remember, if they tell you to sketch your graph on, like, because here they say sketch the graph for the values of x between 0 and 360. If they tell you to sketch it between, say, 360 and 720, so for x between 360 and 720, then remember, when you draw your graph, it's going to look like this, and you're going to start here at 360, and you're going to go all the way up to 720, and you're going to draw your graph there. And they could also say sketch it for x minus 180 to 180, in which case your graph would look like that, minus 180 all the way up to 180. So that's just another thing to remember about when you're sketching trig graphs. But other than that, there's really not much to it. Pop it into your calculator and it's going to give you the answer. It's going to give you this table. Or you can manually do this table using your calculator to calculate each entry into the table. So yeah, just practice drawing one or two of them. Draw the ones that are in your books. When you have your book, it's on page 545 and 546. Like, just practice using the table mode on your calculator to actually generate the same tables that are in your book, and make sure you get the same tables, because then you know that you're doing it right. Example 34 says sketch the graph of y equals tan x. Okay. Sketch the graph of y equals tan x for values of x between 0 and 75 degrees, 105 to 255, and 285 to 360. Okay, so what you're going to do is you're just going to make another table. So you're going to select x and y, and you're going to make your table, and you're going to put there maybe 0, 30, 60, 75. You see, because we can't go up to 90 because it says sketch from 0 to 75. So that's our first interval. Okay, so we stop there. Then 105 to 255, so we're going to carry on again at 105. So let's do that. 105, 120, 150, and 180, and 210. Okay, so we're going to sketch up till there. And up to 240 actually. 240, then 255. Okay. And then we're going to stop there, and then we're going to continue again at 285. 285, dot, dot, dot. And we're going to carry on. And these values are going to be confusing. Let me just write them in for you. So we've got 0, 0, 6, 1, 7, 3, 7, negative 3, 7, negative 1, 7, negative 0,6, 0, 0,6, 1,7, 3,7, negative 1,7. Now, you see how the values are increasing, 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 then they jump to negative. Then they increase, 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 up to 3.7, then they jump back down to negative. So what's happening there is that the tan graph is discontinuous. It has asymptotes. So we were sketching for positive values only. So what's interesting about the tan graph, 60, 90, 120, 150, 180, 210, idiot, I suppose it's fine, 210, 240, 270, 300, 330, 360. The tan graph has asymptotes every 90 degrees. So there's an asymptote here, an asymptote here, I lie. It's got an asymptote at 90 degrees and then every 180 degrees thereafter. So the next asymptote lies at 270 degrees. And the next asymptote is going to lie at, it's going to be off our graph, 270 plus 180 degrees, which is somewhere there. Okay. Then, if we look on the negative scale, our asymptote here will be at negative 90. Okay. So, how the tan graph looks. Okay, so if we start, x equals 0, y equals 0. That value is here. Then 30 degrees and 0.6, 60 degrees and 1.7, 75 degrees and 3.7. Okay. Then you see we reach our asymptote at 90 degrees and the graph, if we look at our values here, there it jumps to minus 3.7. So what happened is we went to here. And we had 120 and that. And then we reach our asymptote again, and it jumps back down. Okay, so our tan graph looks like this. If we just plot through those points, okay, and there is your graph of tan. And remember they asked us to sketch from 0 to 75, so I just wanted to show you that it carries on here like that, and it does carry on the negative side. It will carry on doing that, but they asked us to plot from here and onwards. Okay, so yeah, that's your tan graph. You'll notice that starting at 0, let me get a different color here. Starting at 0, and every 180 degrees, the tan graph crosses 0. So there it crosses 0 at 180, there it crosses at 360. So you see, that's 180 degrees, that's 180 degrees, and you see how it crosses 0 and it repeats. See? It starts at 0 and goes up. Then 180 degrees later, it starts at 0 and goes up. Then 180 degrees later, it actually would have done that. But they told us to stop at 360, so we stopped. Okay, so things to know about the tan graph. Starts at 0, 0. Crosses 0 at 180 degree 180, 360, 360 plus 180, etc. So it crosses 0 at 180 degree intervals. Okay. Also crosses 0 at minus 180. It crosses 0 as well. So 180 degree intervals in both directions, negative and positive. And then it has asymptotes. You've got your asymptotes at 90 degrees, and then at 90 plus 180, and at 90 plus 2 times 180. So basically, your asymptote starts at, your first asymptote is at 90 and minus 90, and you have an asymptote every 180 degrees after that in either direction. Okay? So yeah, that's it for the tan graph. And remember just that when you've got the asymptotes, the graph gets closer and closer and closer and closer to that line, but never touches it. Closer and closer and closer, but never touches the asymptote. Both on both the positive and the negative sides. Okay. And cool. I'm going to stop there. So that's the end of our video today. Thank you very much for watching. Cheers.